In this lesson, we are going to learn how to solve rational equations. We are going to work in section 9.6 on page 762 from your textbook. We're going to work problem numbers 10 through 36 even, but we're not going to do problem number 26. Now, the directions tell us to solve each equation. That's all really that they give us. So what we need to do is first look and see what we have. We know it's an equation because it has an equal sign, and we notice that we have fractions. So whenever I teach this in class, I always ask my students who likes fractions. Normally we come up with the answer that nobody does. So we decide to get rid of the fractions. So what makes something a fraction? Well, if you have a denominator that is any number other than 1, sorry about that, then you have a fraction. So our goal is to make each one of these numbers a 1. So we need to find out what number 12, 3, 6, and 4, meaning all of our denominators, what number do they all divide into? That answer would be 12. Oops. So I'm going to multiply each fraction, each term, everything that has a denominator, we're going to multiply by that 12. Okay? So now before we move on, let's imagine all we had was this. If I had a denominator of 12 and a numerator with a 12 and an x, I would say that 12 goes into both of these one time, and 1 times x is x. So if all I have is this, I would say my denominator is 3. 3 goes into 12 4 times. 4 times 2 is 8. And I'm going to bring that minus sign down. Bringing down my equals. So let's say what we had was this. 6 goes into 12 2 times. So 2 times x is 2x. I'm going to bring down that plus sign. 4 goes into 12 3 times. So 3 times 3 is 9. Now hopefully this is an equation that you would be comfortable solving. First we need to get all of our x's on one side, so we're going to move the smaller of the two. Well, 1x is smaller than 2x, so I'm going to subtract x from both sides, which gives me -8 equals x plus 9. And then you subtract 9 from each side, which gives us -17 equals x. And that is our answer for problem number 10. So when we look at problem number 12, we have 3 over x equals 5 over 3 minus 7 over x. So when we find what we're going to multiply by, it has to incorporate everything that we have in our denominators. So we know it's going to have an x, and we know it's going to have a 3, and then that x. So I'm going to choose to multiply everything by a 3x. Sometimes using a different color might help you when looking at these problems. It might help you see what you've crossed out and what you have left over. So these x's here are going to cancel out. And I apologize for the cat meows. They're in what I like to call crack kitty mode. So 3 times 3 is 9. And this 3 are going to cancel, leaving us with x times 5 is 5x. And then this x and this x are going to cancel, leaving you with 21. I'm going to bring that negative sign down. So I'm going to add 21 to both sides, which gives us 30 equals 5x. And then we divide both sides by 5 to get x equals 6. Now this problem is a little bit different. Anytime you have an x in your denominator, you're going to have what are called excluded values. Okay, this is kind of a fast track way to check your answer. We know that we can never have a fraction have a 0 in the denominator, okay? So it's excluded values are what would make our denominator 0. So we look at all of the denominators that have an x, a y, anything like that in them. So before we started this problem, there was an x here and an x here. So I need to find out what number do I plug into those x's that would give me a 0 in the denominator. Well, I'm not trying to trick you here. This one's just a little bit obvious. So 0 is the only thing I could plug into x that would make that denominator 0. So that is called my excluded value, meaning x cannot equal, that's what that symbol means, 0. So that means if we get a 0 for our answer, then we can't use that as a solution because it's a false solution. It doesn't work, okay? But in this case, we got a 6. We didn't get our excluded value, so we are good to go so far. We are going to practice learning how to find our excluded values, and you actually won't find one of these problems until we get later on into the lesson. So just to give you kind of a heads up, you won't really see one of those for a little bit. So now let's look at problem number 14. On problem number 14, I have 7 over 6x minus 1 over 3 equals 1 over 2x. So I know that what I multiply by is going to have to incorporate an x because I've got x's down here. So I know that has to be in there. And then I've got a 6, a 3, and a 2. So what number do all of those go into? Well, that answer is 6. So I'm going to multiply everything by that 6x. Turn the brightness down just a little bit, see if it makes it a little bit easier to see. There we go. Okay, so now that 6x and 6x are going to cancel, leaving me with just a 7. 3 goes into that 6 2 times. So 2x times 1 is 2x equals, and then those x's here cancel, and then 2 goes into 6 3 times. 3 times 1 is 3. So now to solve, we're going to subtract 7 from each side, which would give us a negative 2x equals a negative 4. And then we divide both sides by negative 2 to get x equals a positive 2. Now, before we can say this is our answer, we have to check our excluded values. So we had a 6x for our denominator and a 2x for our denominator. So those are the only ones that had an x in them. Remember, those are the only ones that give us an excluded value. And I set them equal to 0 because if you set them equal to 0 and solve for x, that tells you what your excluded values are. So I divide by 6, x equals, anytime you have 0 divided by a number, that answer would be 0. Divide this side by 2, same rule applies. So here we have the same excluded value, x cannot equal 0. Well, since we got a 2 for our answer, we know we are good to go because 0 is not the same as 2. Problem number 16, I have 5 over x minus 2 equals 4 over x plus 1. So I'm going to multiply by both of my denominators, because when in doubt, just use whatever denominators you have. So I'm going to multiply by an x minus 2 and an x plus 1. And I do them up and down like this just because it's a little bit easier for me to organize them. You could have written them long ways like you're used to if you wanted to do it that way. So my x minus 2 and x minus 2 cancel. My x plus 1 and my x plus 1 cancel. So that gives me a 5 times x plus 1 equals a 4 times x minus 2. So to solve, I distribute to get rid of my parentheses. So that gives me 5x plus 5 equals 4x minus 8. Move the smaller x over, so I'm going to subtract 4x from each side to get x plus 5 equals negative 8. Subtract 5 from each side to get x equals negative 13. So excluded values. We set our denominators that we had equal to 0. So my first denominator was x minus 2. I set it equal to 0. Second denominator was x plus 1. Set it equal to 0. Now, when you learn about excluded values, if you remember the video that I taught over 7.4, solving radical equations, we talked about checking your answers, and I basically put it to you like this. If you don't check your answers, then you're kind of gambling, okay? It's like if you were to walk out into the street, and if you don't look both ways before you cross, you're taking a gamble. Either you're going to get struck by a car, or everything's going to be okay. You're taking a chance. So you are taking a chance by not checking your answers. So I'm not going to check and make sure you look to see if these were excluded values. I'm not going to check that, but you do need to make sure that you check those out. So when I solve for x on both of my denominators, I got x cannot equal 2 and x cannot equal negative 1. Well, since we got a negative 13 for our answer, it was not one of our excluded values, so we are good to go. Problem 18. I've got 6 over x plus 3 equals 3x over x plus 1. Well, the very first thing that I'm going to have you do is put that 3 over 1. It's easier for my visual learners to see where the numerators and denominators are. Then I'm going to look at what all of my denominators are. I have an x and I have an x plus 1. Well, whenever we are getting a common denominator, say we had 1/2 plus 1/3. Well, if I wanted to get a common denominator, you would tell me I had to multiply this side by 3 and this side by 2's. Okay? Well, we can only multiply to change a fraction. You cannot add or subtract, because if that was the case, I could have just added 1 to the denominator and the numerator and be done with it. So that's why we have to multiply them, and our denominator or our multiplier would be x times x plus 1. You can't just use x plus 1. So this x and this x are going to cancel. X plus 1 and x plus 1 are going to cancel. So I'm left with 6 times x plus 1 plus 3x times x plus 1 equals 3x times x is 3x squared. So we're going to have to distribute a little bit before we can figure out what x is. So I'm going to distribute that 6 and distribute that 3x. So 6 times x is 6x. 6 times 1 is 6. 3x times x is 3x squared. 3x times 1 is 3x. So the first thing I'm going to do is put these in descending order and combine the like terms. So my 3x squared comes first. I'm going to cross them out as I use them so I don't get confused. 6x and 3x are 9x. And then I have my 6. And then I'm going to pull that 3x squared down. Well, anytime that you have something that's an squared, if you have x squared, y squared, z squared, you're always going to move everything over to the side with the x squared as if it's kind of a gravitational force going towards it. So I'm going to move this 3x squared over. And hopefully you notice that your 3x squareds are going to cancel out on both sides, which leaves you with 9x plus 6 equals 0. Subtract 6 from both sides to get 9x equals negative 6. And then divide both sides by 9 to get x equals negative 2/3. Well, before we move on, let's check our excluded values. I had a denominator that was an x, so I'm setting that equal to 0. And a denominator that was an x plus 1. I'm going to set that equal to 0. Well, this one's already set equal to 0, so I know that's an excluded value. So we cannot have a 0. And then I subtract 1 from each side to get x cannot be negative 1. So we got negative 2/3. It doesn't match either one of the excluded values that we found. So negative 2/3 is a good solution. You might not find very many problems that don't work in this lesson. However, you know I'm going to put one on the test like that, at least one, where they don't work. So just make sure you get in the habit of checking those now. So number 20, we've got 7 over x minus 2 over x minus 3 equals 6 over x. Remember, we can't just subtract 3 from both of these. We have to actually use x times x minus 3 as our multiplier. So our x's cancel out, our x minus 3's cancel, and then these x's are going to cancel out. So I'm left with 7 times x minus 3 minus that x times 2 is a 2x equals 6 times x minus 3. Some of you guys might be tempted to go ahead and multiply out. Make this a little bit bigger for y'all. Some of you guys might get a little bit tempted to go ahead and distribute that 7 out and that 6 out up here. I do not recommend doing that. You'll end up making some mathematical errors. So I recommend writing all of it back out and then just taking that little bit of extra time to multiply those out later. So I'm going to distribute my 7 here and my 6 here. So 7 times x is 7x. 7 times negative 3 is negative 21. Bring down my negative 2x equals 6 times x is 6x. 6 times negative 3 is negative 18. Now I'm going to combine my like terms to get 5x minus 21 equals 6x minus 18. I move the smaller x to the other side to get negative 21 equals x minus 18. And then I add 18 to both sides. So I got negative 3 equals x. So our excluded values, we had a denominator that was a 0, a denominator that was an x, set it equal to 0, so one of our excluded values was 0. And then I had a denominator that was an x minus 3. We'll set it equal to 0, add 3 to both sides. Your other excluded value is a positive 3. Well, that positive 3 is different than the negative 3 that we found, so we are okay with our solution here. Problem number 22, I have 10 over 2x plus 6 plus 2 over x plus 3 equals 1/2. So before we multiply by anything here, we need to go ahead and factor any denominator that can be factored. So notice we can pull a 2 out of this denominator, which would leave us with an x plus 3. Okay, so I just made it look different. I didn't change the problem, it just looks a little bit different. So notice we have an x plus 3 in both of these, and then we have 2's in both of these. So I'm going to multiply by 2x plus 3. Okay, so this whole denominator here will cancel. My x plus 3's will cancel, and my 2's will cancel. So I'm left with 10 plus 4, because 2 times 2 is 4, equals x plus 3. Anytime you multiply a number times 1, you get that number. So now 10 plus 4 is 14, equals x plus 3. Subtract 3 from both sides to get 11 equals x. Our excluded values, well, I had a 2x plus 6, an x plus 3, and that 2 doesn't matter because it did not have a x in the denominator. So I subtract 6 from both sides to get 2x equals negative 6. Divide both sides by 2 to get x equals negative 3. So negative 3 is an excluded value. And then if we subtract 3 from both of these sides, we also get a negative 3. So we know negative 3 is a solution we cannot have because that's what would give us a 0 in those denominators. We got 11, so we know our answer is okay. Now let's look at problem number 24. On 24, we have x over 4x minus 12 minus x minus 4 over x minus 3 equals 1 over 8. Well, let's go ahead and factor this denominator here. It's the only one of these that can be factored. So I can pull out a 4, and I'm left with x minus 3 inside of those parentheses. So I know x minus 3 has got to be a part of our multiplier because I've got an x minus 3 on both of these. So those are taken care of. Now we have a 4 and an 8. So the common number that both of those will go into would be 8. So I'm going to multiply by 8 times x minus 3. So my x minus 3's cancel, and 4 goes into 8 2 times. X minus 3's cancel here, and my 8's cancel here. This is a prime example of why I do not recommend distributing first. 2 times x gives me a 2x. You might be you might think that you could go ahead and multiply that 8 times each of these, but it's actually a negative 8 times x minus 4. So if you're one of those who's tempted to go ahead and distribute first, this is an example of a problem where you would get wrong because you're not paying attention to that negative in front. So I distribute my negative 8. So I have So I have 2x minus 8x plus 32 equals x minus 3. Now I combine my like terms to get negative 6x plus 32 equals x minus 3. Add 6x to both sides, which gives you 32 equals 7x minus 3. Add 3 to both sides to get 35 equals 7x. Divide both sides by 7 to get x equals 5. So those excluded values, let's talk about those. So we had a denominator of 4x minus 12 and a denominator of x minus 3. We're not worried about that 8 because that denominator did not have an x in it. Add 12 to both sides to get 4x equals 12. Divide both sides by 4 to get x cannot equal 3. Add 3 to both sides on this one to get x cannot equal, again, 3. So we got 5 for our answer, so we know we are good to go. As it stated in the very beginning of this lesson, we are not going to do problem number 26. So we're going to jump on to problem number 28. 28 says we have 1 over x plus 4 plus 1 over x minus 4 equals 12 over x squared minus 16. So the first thing I need to do is factor my denominators that can be factored. Well, this one factors to be x plus 4, x minus 4. So I know I have to incorporate an x plus 4 and an x minus 4, and these are the same as the first two. So we just multiply by x plus 4, x minus 4. Okay, so my x plus 4's cancel, x minus 4's cancel, and then both of those will cancel. So I'm left with 1 times x minus 4 plus 1 times x plus 4 equals 12. Well, when you distribute those ones, and I'm doing that just in case there was a negative there, I'm going to distribute those to get x minus 4 plus x plus 4. X plus x is 2x, not x squared. Those 4's cancel, leaving us with 12 on the other side of the equal sign. Divide both sides by 2 to get x equals 6. Excluded values. We had an x plus 4 and we had an x minus 4. Alright, so to get this one by itself, we would subtract 4 from both sides to get x cannot be a negative 4. Then we would add 4 to both sides here to get x cannot equal a positive 4. Well, we got a 6, so we know we're okay there. Alright, so that was problem number 28, so let's look at number 30. 30, we have 2 over x minus 2 equals 3 over x plus 2 plus x over x squared minus 4. So I'm going to factor my denominator to get x plus 2, x minus 2. So I know I have to multiply by x plus 2 and x minus 2 because that incorporates all of our denominators that we have. So my x minus 2's cancel, my x plus 2's cancel, and then all of those are going to cancel on that last one. So I'm left with 2 times x plus 2 equals 3 times x minus 2 plus x. So I'm going to distribute to get 2x plus 4 equals 3x minus 6 plus x. So now I'm going to combine my like terms. I'm going to bring down that 2x plus 4. 3x plus x is 4x. Bring down your minus 6. Subtract 2x from both sides to get 4 equals 2x minus 6. Add 6 to both sides to get 10 equals 2x. Divide both sides by 2 to get x equals 5. If I went a little too fast on you on that one, then go ahead and feel free to rewind. So excluded values, I have an x minus 2 and an x plus 2. Remember, you set each denominator that you had equal to 0. And since this last one incorporated the x plus 2 and x minus 2 we've already accounted for here, we don't have to redo those. So I add 2 to both sides here to get an x cannot equal a positive 2. Subtract 2 both sides here to get x cannot equal a negative 2. So since our answer was 5 and not a positive or negative 2, we are still okay. Okay, so let's go ahead and look at problem number 32. On 32, we have 3 over x minus 4 minus 4 over x squared minus 3x minus 4 equals 1 over x plus 1. When you factor this out, you get x minus 4 and x plus 1. It won't always work out this way where you end up with what the other denominators are, but a good bit of the time it will. So we're going to multiply by x minus 4, x plus 1. So my x minus 4's cancel. My entire denominator cancels with all of that multiplier. And then my x plus 1's are going to cancel. So I'm left with 3 times x plus 1 minus 4 equals 1 times x minus 4. We're going to distribute to get rid of those parentheses. So that gives me 3x plus 3. Bring down your negative 4 equals x minus 4. Combine your like terms to get 3x minus 1 equals x minus 4. Subtract x from both sides to get 2x minus 1 equals negative 4. Add 1 to both sides to get 2x equals negative 3. Divide both sides by 2 to get x equals negative 3 halves. For excluded values, you had x minus 4 and x plus 1. So you could not have a positive 4, and you cannot have a negative 1. Since we did not get that for our answers, we are okay. Problem number 34, we have 3 over x plus 1 minus 5 over x plus 6 equals 2 over x squared plus 7x plus 6. So to factor this out here, we would get x plus 1, x plus 6. And that's exactly what we're going to multiply by. My x plus 1's cancel. My x plus 6's cancel. And then my x plus 1 and x plus 6 will both cancel on the right side. So I'm left with 3 times x plus 6 minus 5 times x plus 1 equals 2. So we're going to distribute that 3 and we're going to distribute that negative 5 to get 3x plus 18 minus 5x minus 5 equals 2. Combine your like terms. 3x minus 5x is negative 2x. 18 minus 5 is 13. Subtract 13 from both sides to get negative 2x equals negative 11. And then you divide both sides by negative 2 to get x equals a positive 11 over 2. I got that because a negative divided by a negative gives you a positive. So now, excluded value time, you had an x plus 1 and an x plus 6. So you could not get a negative 1 or a negative 6 for your answer. We didn't get any of those, so we are okay. Problem number 36, so the last problem for this lesson. We have x over x minus 5 plus 2 equals 5 over x minus 5. Remember, if everything does not have a denominator, please put it over 1. And it's easy to see on this one that your common denominator is going to be x minus 5. That's what we're going to multiply by. So your x minus 5's cancel here and here. So I'm left with x plus 2 times x minus 5 equals 5. So I'm going to distribute that 2 to get x plus 2x minus 10 equals 5. X plus 2x is 3x. Add 10 to both sides to get 3x equals 15. And then divide both sides by 3 to get x equals 5. So now let's check out our excluded values. We have x minus 5, and we have that for both of our denominators with x's, so I only need to write it once. So I add 5 to both sides to get x cannot equal 5. Well, if you notice, your excluded value is the same value that we got for our answer. So in that case, this answer does not work, and you would write no solution. Now that does conclude the last problem we are going to do in this lesson. I will give you a little bit of a heads up that you will encounter problems on your exam where you are going to have to get everything on one side, factor, and then solve both of those binomials. If you need examples of those, you can look back at 7.4. Those types of problems were more towards the end of the lesson. I hope that this has helped you, and I wish you the best of luck.